students, welcome back. This is Torres, elbow bump. How are you? Are you doing okay? Is your family okay? Remember, if you need anything, please send me an email, and I promise to do whatever I can to try to help. So lucky you, you get to hear my voice for another lecture. But the best part is we will be doing another example of how to use the 4 steps of hypothesis testing for proportions using a z-test. Yay! Before we start today's example, let's quickly review the 4 steps of hypothesis testing. The first step is to state your hypotheses. You're going to state the null hypothesis and the alternate hypothesis. The null hypothesis describes the status quo. It is what is believed to be happening in the population and what would continue to happen if there is no change. The alternate hypothesis describes the question. In both instances, the null and the alternate must be written in terms of the population parameter. So if you're working with proportions, you're going to use the notation of P. If you're working with means, you're going to use the notation of mu. The second step is the prepare step. This is usually the longest step. In this step, you're going to do things like choose the significance level, decide what kind of test you need. Do you need a test that is looking for any change, for values that are significantly lower than the mean or proportion, or values that are significantly greater than the mean or proportion? You're also going to look up your test statistic that describes the z-score for your significance level for the test that you chose. If necessary, you need to check the requirements to make sure that your data is normally distributed. In this step, you will also calculate the standard error. This is also the time where you should draw your model and section out the areas of rejection and the area of retention. In the compute to compare stage, you're going to be calculating your test statistic for your sample. In these scenarios, you will be calculating your z obtained in this step. You calculate your z obtained by using the z-score formula that takes the sample information. From that, you're going to subtract the population information and divide that number by the standard error. That will give you your z obtained. You will need to use technology to find the probability of the z obtained. If the probability of your z obtained is less than your stated alpha, then you should reject the null hypothesis. If the probability of your z obtained is more than your stated alpha, then you should retain the null of no difference. The final step is to interpret your results. In this step, you're going to make a decision on whether you're going to reject or fail to reject, in other words, retain the null hypothesis. You should state your conclusion in the context of the study. Let's look at this example about restaurants. It says, 90% of all restaurants fail after 1 year. Is that number different for Chinese restaurants? Out of a random selection of 108 new Chinese restaurants, 87 had failed after 1 year. Use a 5% significance level to test your hypotheses. Okay, so I have gone ahead and cut-pasted the important information into Ziteboard. In this top part, I have gone ahead and cut-pasted the steps of hypothesis testing, and then down here I cut-pasted our restaurant question. As a reminder, the Google Slides and the Ziteboard links are in the description box below, so you can have access to all of this stuff even if you don't watch the video. Okay, so it says 90% of all restaurants fail after 1 year. So this is telling me that there's a percent right here, so this is going to end up being a proportion. Okay, is that number different for Chinese restaurants? Out of the random selection of 108 new Chinese restaurants, 87 had failed after 1 year. Okay, so we're going to start off by doing our hypotheses, and our hypotheses are going to be in green. That's what I've been doing. So we're going to write the H naught. The H naught is the status quo. It's what's expected to happen. So this is our status quo, 90%. Since it's a proportion, I'm going to use the notation of P, and I'm going to write 90% as a decimal. So here is my null hypothesis. The alternate hypothesis is going to address the question. So the question is that number different? It does not say, is that number less? Is that number more? It says, is that number different? So for different, I can use HA, right, my alternate hypotheses, P, because I'm still working with a population proportion, not equal to, so it's not one directional. We're looking at the two extreme tails, and the population proportion is going to stay the same here. So my H naught is P equals 0.9, and my HA is P is not equal to 0.9. Okay, so we're done with the hypothesis step. Now I'm going to go ahead and go into the prepare step. And remember, the prepare step is often the longest step. So let's go ahead and start writing some of this information out so that we have it handy. We have our proportion, our population proportion was 0.90. We had that our sample size was 108. We have that our alpha is 0.05. Let's calculate our p hat. So the p hat is going to be 87 out of the 108. And I'm going to go ahead and bring my Google Calculator over. And clear this out. And I have 87 divided by 108. And I get, let's just say 81%. So we've got 0.80555555. So I'm going to write that down, 8055, and then this is approximately 81%. Okay, great. Now, what kind of test do I need? Well, this is looking for either extremely low values or extremely high values. So this looks like a two-tailed test. A two-tailed test. So I'm going to go ahead and go over to my ZCrits for common significance level. I need a two-tailed hypothesis test, and I need it for a 5% alpha. So my ZCrit is going to be positive 1.96 and negative 1.96. So my ZCrit equals positive and negative 1.96. Okay, and I'm going to go ahead and scooch this up. Okay, fantastic. Now, I could start making my model, but since I'm already calculating stuff out, let's see if this meets the condition of the central limit theorem, because I don't want to go too much further if I haven't checked this. So let's check the conditions of the central limit theorem. So number one, is it random and independent? Well, it does say random selection, so that's stated here in the problem. It does not say independent, but I'm going to go ahead and give it the benefit of the doubt. Number two, we need a large sample. So that means my successes have to be larger than 10, and my failures have to be larger than 10. So for my successes, I've got n times p, which is the same as 108 times 0.90. And I'm going to go ahead and bring this over here. Clear? 108 times 0.90 equals 97.2. So I'm going to go ahead and just say 97, because you can't have 0.2 of a restaurant. So 97, is that greater than 10? Yes, so that checks out. So now I need to know what the failures are. Well, if there's 108 restaurants and 97 of them are considered a success, then the difference would be considered a failure. So the difference between 108 and 97 is 11. Is 11 greater than 10? Yes, it is. It came close of not meeting the conditions, but it made it. So we're good. Whew. Okay. The last condition is large population. That means that the population has to be bigger than 10 times the sample size. So the population has to be bigger than 10 times 108, and the population has to be bigger than 1,080. And is there more than 1,080 Chinese restaurants? Oh yes, check. So this does meet the conditions of the central limit theorem, and we can assume normality. Woohoo! Okay. Now let's make myself my model here. Here is my model. My Z's. This is my P. Okay, let me fill in my Z-scores. And my middle value here, the proportion that aligns with the 0 Z-score, is going to be the proportion that we used in the null and alternate hypothesis. So that's going to be 0.9. Okay, 90%. Now we need to find this distance. So we're going to find that distance with our standard error formula. And for proportions, this is our standard error formula. Okay, it's going to be the population proportion multiplied by a whole minus the population proportion divided by the sample size, and then you take the square root of that number. So let's go ahead and plug stuff in. So my proportion was 0.9. 1 minus 0.9 divided by, what was my sample size? 108. Okay, where's my Google Calculator? Google Calculator, clear this out. So I've got 0.9 times parenthesis 1 minus 0.9. That's my numerator. Divide that by 108. And then finally, take the square root. I like to hit square root and then answer, and I can save myself the trouble of trying to put all those numbers in again. And I get 0.0288. Okay, and I'm just going to round this to 0.03 just to make my life a little bit more simple. I'm just going to say this is 0.03, and I'm going to go ahead and write out my theoretical raw scores. So this is going to be 0.93, 0.96, 0.99, and in the opposite direction it's going to be 0.87, 0.84, 0.81. Okay, awesome. Now let's go ahead and mark my areas of retention and rejection. So here I'm going to go ahead and do this in blue so I stay consistent. Remember, this time we have a two-tailed test, right? So we are going to have to mark both tails. That's why it's called a two-tailed test. So we need to mark an area of rejection at positive 1.96. So positive 1.96 is really, really close to 2. Okay? And everything greater than that is going to be an area of rejection. The other tail is also going to need to be marked, and it's going to be marked in a symmetrical way. So it's going to go right over here at negative 1.96. And so everything less than that is also going to be an area of rejection. This is going to be the area of retention. Okay, so you're going to retain in through here, reject if you get a z-score that is more than positive 1.96, and you're going to reject if you get a z-score that is less than negative 1.96. Okay, so that is our compare and contrast step, and we're going to go ahead and go to our compute and compare. To try to be consistent, I will do the compute and compare step in this pink, fuchsia, magenta color. Nobody's telling me whether this is magenta or fuchsia. Help me out, please. So leave a comment below. All right, so in the compute to compare, I need to compute my obtained z-score. So I'm going to go ahead and I'm just going to do it over here. So my z obtained follows this formula. I'm going to take my p hat, and from that I'm going to subtract the population proportion and then divide it by the standard error. Okay, let's plug everything in. So my z obtained is going to be my 0.855 minus 0.9 divided by 0.0288. And let's bring over Google Calculator. So I'm going to clear this out. Clear, clear, clear. 0.855 minus 0.9. I've got negative 0.045. I'm going to divide that by my denominator, which is the standard error, which is 0.0288. And I'm going to get a z obtained of negative 1.5625. Let's see where this thing is falling. So this thing, I'm going to blow this up a little bit. Okay, so negative 1.56 is actually going to be right about here. See that? It is in the area of retention. So this is my z obtained of negative 1.5625. So this is looking like it's going to be retained. Now I need to check my alpha. Before I do, I want to remind you of one thing. So back here, we said that our alpha was going to be 5%, right? We have an alpha of 5% for a two-tailed test. So with a two-tailed test, this section and this section make up 5%. So they have to be distributed equally. So there is 2.5% alpha on the left side, 2.5%, and 2.5% on the right side. So if we're looking at this z obtained, we need to see how much is to the left of that z obtained and compare it not to 0.05, but to 0.025. Okay, so let's go over to our normal distribution calculator. So here is the free normal distribution calculator. The link to this is in the description box below. In our model, our mean was in the center. So our mean is going to be the 0.9. And the standard error was the one that we calculated using our sample size. So that's going to be 0.0288. Now we're going to look for values that are below the particular p-value that we used from our sample, right? So our sample p-value, in other words, our p-hat, was 0.855. And I'm going to show me the explanation. Now remember, this is checking our alpha against our p-value. The alpha is not 5% all on the left tail. It's 5% in the left tail and the right tail split up equally. So we need to make sure that if we're going to reject, we can only do that if this p-value is less than 2.5%. So let's go ahead and compute. we have a p-value of 0.0594. Okay, so it's right about here. In our model, we had established that the negative 1.96 z-score was very close to 84. And we had said that anything less than that would be rejected. Since this value is more than that z-score and there is more of the curve, we have 8% of the curve in here, and we only were supposed to have a maximum of 2.5% of the curve in here, there is not enough evidence for us to reject the null hypothesis. So to recap, our z obtained was negative 1.56, and this number, the z-score, falls in the area of retention. The probability of our z obtained is 0.08. This number exceeded our alpha of 0.025, which is this amount of probability that is on the left tail. This is 1/2 of our total alpha. So according to our calculations, there is not enough evidence to reject the null of no difference, so we must retain. Okay, so we retained because of this, and we retained because of this. In the last step, we make the decision and put it in the context of the scenario. So we're going to say that we're going to retain the null hypothesis of no difference because there is no statistically significant evidence to support the claim that the percent of Chinese restaurants that fail after 1 year is different from the expected percentage or the expected proportion of the population, which is 90%. Okay, let's quickly recap what we've done. So the scenario said 90% of all restaurants fail after 1 year. Is that number different for Chinese restaurants? Out of a random selection of 108 new Chinese restaurants, 87 had failed after 1 year. Use a 5% significance level to test your hypothesis. In the first step, we wrote our hypotheses. The null hypothesis had the percentage of restaurants that were expected to fail, and that was 90%. The alternate was looking to see if that number would be different. So that's why we use the not equal sign here for the alternate. In the prepare phase, we did a lot. We wrote down all our knowns over here, which was our expected population proportion, our sample size. We figured out what our p-hat would be. We decided that we needed a two-tailed test. And because we were working with an alpha of 0.05, we found our ZCrit would be positive 1.96 and negative 1.96. Before we went any further, we went ahead and checked the conditions of the central limit theorem to show that we could assume normality in our model. We also calculated our standard error. Then we created our model here. We wrote out the z-scores. We just made some really coarse estimations here to establish where our theoretical raw scores would fall. And we marked the area of rejections. For the left area of rejection, which contained half of the alpha, so half of the 5%, in other words, 2.5%, we marked it here. Everything less than that would be rejected. We did the same thing in the right tail. We marked our ZCrit of positive 1.96. We marked that any z-score greater than positive 1.96 would be in the area of rejection, and this area comprised half of our alpha, so it's half of 5%, in other words, 2.5% alpha. In the compute to compare stage, we went ahead and computed our z obtained. The z obtained for our sample showed that if we had 85.5% of the Chinese restaurants in our sample fail, by calculating the z-score, we would have an obtained z-score of negative 1.56. A z-score of negative 1.56 fell in the area of retention because we were looking for anything that was less than negative 1.96 to reject. So negative 1.56 is in the area of retention. We also look to see what is the probability of obtaining a z-score that is less than negative 1.56. That probability is 8%. Since 8% is more than half of our total alpha, in other words, since 8% is more half of 5%, so in other words, since 8% is more than 2.5%, that is also an indication that we should retain the null of no difference. So looking at our obtained z and where that falls, it's saying retain. Looking at the probability of our obtained z, that's saying retain. They match, so we are going to retain. In the last step, we have decided that because our p-value is greater than our alpha, we're going to fail to reject. In other words, we're going to retain our null hypothesis. And we're going to state the conclusion in the context of the study by saying there is no statistically significant evidence to support the claim that the percent of Chinese restaurants that fail after 1 year is different than 90%. And of course, 90% was the estimated population proportion. So what's the big idea? Today's big idea is that the 4 steps of hypothesis testing provide a systematic process to answer a research question concerning the population parameter. The 4 steps are hypothesis, prepare, compute compare, and interpret. So that's it for today. With that said, don't forget to check your emails, check Blackboard, do your homework, and subscribe to this channel. Even better, hit that notification bell so you know when there are new videos for this course. Okay, this is your teacher Taurus saying stay safe, and I will be waiting to give you a virtual elbow bump in the next video. Ciao!